Welcome to The Explainer. Today, we are taking on the future of artificial intelligence. But forget the sci-fi stuff for a minute. The robot overlords, the super intelligent brains in a jar. We're actually going to tear down that whole vision to get to something way more powerful and, honestly, a lot more useful. A future for AI that's built around us, around humans. So, let's get into it.
All right, I want to start with a question that's going to sound a little weird. Are you hallucinating right now? Seriously. And believe it or not, the answer, according to modern neuroscience, is yeah, you kind of are. To get why that is, we need to talk about how your brain really sees the world. You see, your brain is locked in the dark, inside your skull. It doesn't actually see or hear anything directly. So what does it do? It makes predictions. All day, every day, it's making its best guess about what's out there. And it uses the data from your senses, your eyes, your ears, to check its work and fix the mistakes. Neuroscientists have this amazing name for it, a controlled hallucination. And that word controlled is everything. And that brings us, believe it or not, straight to AI. You hear the term AI hallucination all the time, and we all just think, oh, it's a bug, it's a mistake. But what if that's the wrong way to look at it? What if, just like for us, these so-called hallucinations are actually a feature, a necessary step for an AI to get flexible, to go beyond its training data and think in a more human-like way? The secret sauce, just like with our brains, isn't getting rid of them. It's learning how to control them. You know, this whole idea, control versus just raw power, gets us to a massive fork in the road, a debate about what we're even trying to do with AI in the first place. And this isn't some new agey tech debate. This is a choice we've been wrestling with for more than 60 years. It's really a tale of two completely different visions for the future.
So in one corner, you've got the classic 1956 goal, build thinking machines. The whole point was to solve intelligence inside a computer, to create something that could maybe even replace human thought. But in the other corner, you had these pioneers like Douglas Engelbart. Yep, the guy who invented the computer mouse. And he had a totally different idea. He didn't want to build thinking machines. He wanted to use technology to augment our intelligence, to make us better thinkers. And wow, was Engelbart onto something. As soon as we all got computers, we started doing exactly what he predicted. We started offloading our thinking, right? We used calculators, calendars, search engines. Our minds started spreading out into our devices. It created this powerful feedback loop that scientists call technosocial coevolution. Basically, we build new tech, and that new tech literally changes the way we think. And this loop created this amazing technological flywheel. Every turn just made the next one spin faster. We built more powerful computers, which gave us the internet. All the data on the internet let us build these incredibly sophisticated algorithms. And what did we do with those algorithms? We used them to design, you guessed it, even more powerful computers. It's this self-fueling cycle that's basically defined the last 50 years. Okay, but to really figure out which path AI should be on, we need to rewind. Way, way back. We have to look at the original blueprint for general intelligence, us. How did humans get so smart in the first place? Think about it. When we imagine AGI, artificial general intelligence, we picture this single, brilliant computer mind, right? Like a brain in a box just churning away. But what if that whole image, that entire concept, is just wrong? What if true general intelligence is not something that can even exist inside one single brain? Well, according to evolutionary science, the answer is a hard no. Our own intelligence, the humankind, didn't just pop up in one person's head. It's not something you own by yourself. It's a social thing. It emerges from the interactions between all of us. This actually created its own human flywheel, just like the tech one. Bigger brains let us have more complex social groups. Living in those groups forced us to get really good at reading each other. All those subtle social cues. And getting good at that skill is what drove the evolution of even bigger brains. You see the loop? The big takeaway here is so important. We didn't get smart on our own. We got smart together. The absolute key skill that came out of this social evolution is something scientists call representational alignment. I know, it's a mouthful, but the idea is actually super simple.
It's just the ability to get the picture in my head to match the picture in your head. It's how we get on the same page, how we cooperate, how we build a shared reality. And there was just one cognitive technology, one invention that was the big bang for our ability to do this. And that invention was language. And what's so special about human language isn't just the words. It's the fact that it's built on a shared secret. We both know that our words point to ideas that other minds are thinking up. Language let us realize that other minds even existed, and then it let us use those other minds as the most powerful tools we could ever imagine.
Okay, so if real intelligence is social, if it's interactive, if it's built on a shared understanding, then maybe we should be building AI the same way. This insight points to a totally new path for how we design AI agents.
This quote from Danielle Perzik over at Amazon's AGI lab just nails it. The future isn't one giant AI brain doing everything. The future is built on countless tiny, reliable digital actions, these agent calls. They become the basic building blocks, like Legos, for everything we do online.
So what is this new kind of agent? Well, for one, it's not just a chatbot that gives you text. A computer use agent actually sees the screen, it sees the pixels, and it uses websites and apps just like you do. Its actions are grounded in a world we both share, the browser. And the focus isn't on doing some huge, complex task all at once. Nope. The focus is on making tiny atomic actions, like a single click or filling one box in a form, super reliable. Because once you can do that, you can string those actions together to do almost anything. It's the difference between a read-only assistant and a true partner that can do things for you. And the goal here is amazing. It's to create a common language, a shared understanding between us and our computers. A system where we can teach an agent to do something, and then the agent can learn a better way and teach it back to us. It's a two-way street. We level each other up, back and forth. And this brings us right back to where we started, to that tale of two visions. But now, with everything we've talked about, we can actually redefine the ultimate goal of AGI itself. So the old goal, make AI smarter. We'd measure it in a lab, by itself. The new goal, make humans smarter. The way we measure success completely changes. It's not about the AI's IQ, it's about how good the interaction is between us and the AI. The focus shifts from, can the AI think, to, does this tool help us think better? Does it help us create more? Does it help us solve bigger problems? The result isn't some autonomous agent that could go off the rails, it's a collective tool that makes us all more capable. This is the big shift. This is everything. We stop trying to build an artificial mind, and we start building tools that augment our collective mind. Tools that can become our shared subconscious, handling all the boring, repetitive stuff so we can focus on what humans do best. So in the end, the most important question isn't how smart can AI get? It's how much smarter can AI make all of us together.